Asteroids are small, rocky objects that orbit the sun. They are remnants from the early stages of the solar system, dating back about 4.6 billion years. The process of their formation is closely tied to the solar nebula hypothesis, which describes the formation of the entire solar system. Here's a detailed explanation. 1. Solar nebula. Initially, there was a massive, rotating cloud of gas and dust called the solar nebula. This nebula started to collapse under its own gravity. 2. Protoplanetary disk formation. As the solar nebula collapsed, it flattened into a spinning disk known as the protoplanetary disk. Most of the material collected at the center to form the sun, while the remaining gas and dust in the disk began to clump together due to gravitational forces. 3. Formation of planetesimals. Small, solid particles within the protoplanetary disk began to stick together and collide, forming larger objects called planetesimals. These planetesimals were the building blocks of planets and asteroids. For accretion and differentiation, planetesimals continued to collide and accrete more material. Some grew large enough to become protoplanets, which further attracted material and eventually became planets. Others remained as smaller bodies, such as asteroids. 5. Jupiter's influence. The presence of Jupiter played a crucial role in the evolution of the asteroid belt. Jupiter's strong gravitational influence prevented the material in the asteroid belt from coalescing into a full-size planet. Instead, the gravitational interactions with Jupiter and other factors caused many small bodies to collide and fragment, forming the diverse population of asteroids we observe today. 6. Asteroid types. Asteroids are classified into different types based on their composition. Some are rich in metals, while others are composed of silicate rocks. These variations reflect the conditions and composition of the early solar system. In summary, asteroids originated from the primordial material present in the solar nebula, undergoing processes of accretion and collision in the protoplanetary disk. The gravitational interactions, especially with Jupiter, influenced their development and prevented the formation of a large planet in the asteroid belt. The impact of an asteroid on Earth can have significant and potentially catastrophic consequences. The extent of the damage depends on various factors such as the size, composition, speed, and angle of the impact. Here's a detailed explanation of what might happen. 1. Impact energy. The energy released upon impact is immense. It can cause widespread devastation, ranging from local to global effects. The larger the asteroid, the more energy is released. 2. Immediate effects. Crater formation. The impact can create a crater, and its size is proportional to the asteroid's diameter. A larger asteroid can produce a correspondingly larger crater. Shockwaves and tremors. The impact generates shockwaves that travel through the Earth, causing earthquakes and ground tremors. 3.
If you like this video, please subscribe this channel for more informative videos.